Circuit Sudoku 2. So there's our circuit. All the resistors are in parallel. If we wanted to find an equivalent resistance, we'd have to use the 1/over rule. But what I like to do to start out with is I like to look at my circuit and, if not actually color the wires, I at least like to mentally color the wires. All of those will have the same electric pressure. They will have the same voltage. Now, we don't know what that's going to be, but maybe we'll find out as this all goes on. Similarly, this whole portion of the circuit down here is going to have an identical electric pressure. And since that's connected to the negative battery terminal, which is the low pressure terminal, I like to assign that to be 0 volts. That one we know. And this is just a technique that will help you solve the problem. There's nothing super special about it. So let's see what we've got here. We've stated previously that the two equations that are going to help you work back and forth in this diagram are Ohm's law, which is V is equal to I times R, and then power is current times voltage. If we know I and R for resistor 2, then we know the voltage is going to be 36, 3 times 12. According to what we're told here, we have 2 amps of current that are going through resistor 1. Let me draw that by putting like 2 arrow tails through resistor 1, just for the sake of this problem. We have 2 amps going through resistor 1, so I'm going to draw 2 arrow tails of current. Through resistor 2, we have 3 amps. 1, 2, 3. Through resistor 3, we have 1 amp. I'll draw it over here. Now, if we follow these around the circuit, this 1 amp is all we're going to have in that little bit of the circuit. But right there, where I'm pointing, you see I got 3 amps coming in plus 1 amp coming in. So right here, 1, 2, 3, 4 amps are going to be flowing in that portion of the circuit. Those 4 amps then are going to meld together. This is like cars on an on-ramp going onto the interstate. You got a couple of cars here, and these are the cars that are already on the interstate. 2 come in here plus 4, so that's a total of 6, which means 6 amps are going to be going through the battery. 6 amps, 6 amps, 6 amps, 6 amps. Right here, 2 peel off. The other 4 go this way. Right here, 3 more peel off, leaving you with just the 1 to make that trip right there. We used Kirchhoff's junction rule several times right there. What are we seeing now? I'm seeing across resistor 2, we have 32 volts of electric pressure. That's what we have in the table here. And that means that red to green in my diagram here is 36 volts difference, which means across every element in this circuit, there is a 36 volt pressure difference, which means the resistance that's felt by the battery is going to be 6 ohms. Once again, that's not the resistance of the battery, that's the resistance that the battery perceives as it's pushing charge. This is going to be 18 ohms, and this is going to be 36 ohms. The power is going to be 36 times 6, which is 216 watts. 36 times 2 is 72 watts. 36 times 3 is 108 watts. And 36 times 1 is 36 watts. Those are the resistors. What do those give you? 216. Look at that. The power delivered by the battery is equal to the power consumed by the resistors. Let's try one more. I like to color that. All of this portion of the circuit is going to have the same electric pressure. This is a 12-volt battery, so I'm going to go ahead and label that right now as being 12 volts of electric pressure. This negative battery terminal I always assign to be 0 volts. The pressure of that whole region right there is going to be 0 volts of electric pressure. This portion right here, we don't know what his electric pressure is at the moment. All right, let's see what we got. We know that the resistance that the battery is going to feel is going to be 6 ohms, because by Ohm's law, V is equal to I times R, and the power here is going to be 24, 12 times 2 watts. All right. Well, let's look at our picture now. Look at R3. There's a 12-volt difference in pressure across R3. So that's 12, which means this has got to be what? 12 is equal to what times 15? 0.8 amps. And 12 times 0.8 is going to be 9.6 watts. So that's what we have there. All right, now what do we do? Well, now we say, hey, if we have 2 amps going through the battery, 2 amps, follow my pen, 2 amps, 2 amps flowing, 2 amps flowing, 2 amps flowing. Right here, they split. Some go south through R1 and R2, and the rest go through R3. The amount that goes through R3 is 0.8. So how much must have turned south? 1.2, which flows through both resistors 1 and 2. So now we can multiply these out. That's going to be 7.2, I believe, and 4.8. 7.2 volts and 4.8 volts. And so now I'm going to need a calculator for this. 8.64. 8.64 watts V times I, and this is going to come out to be 5.76. 5.76 watts. There you go. What about if you add these up? Does it give you 24? 13, 22. It does give you 24. Look at that.